Welcome to Math Blossoms, where growing in mathematics is natural. Today's lesson topic is Introduction to Transformations on the Coordinate Plane. Let's get prepared for today's lesson. You're going to need a pencil for today's lesson, preferably with an eraser in case you make errors you would like to correct them. Paper so that you can take notes. Also some graph paper because we are working with geometry. And a ruler or straight edge is optional so that you can draw straight lines, but not exactly required. Don't forget that you can pause the video from time to time to answer the practice questions. That is the best way to learn math, is to try it on your own first and then compare it with the answer to see where you may have gone wrong or if you got it right. Also, you will want to rewind the video if you need to review anything before answering the questions. Okay, we're going to grow our vocabulary today before our lesson. But before we do that, let's go ahead and clear our minds of everything. We're going to do 3 breaths. I'm Miss G, the teacher. And first, I'd like to remind everyone that it does take some deep concentration when we're learning math. So we don't want a lot of distraction. So if we're thinking about things, we need to just try to forget about them for a little while so we can just focus on the math. So let's go ahead and take some deep breaths, and that will help us focus on what we're doing. And as we breathe out, let's just try to, pretend that all of our thoughts are going to just kind of, sit on the couch for a while, and then we'll think about them later on. Okay, let's go ahead. I'm going to breathe through the nose and out the mouth. We're going to do it 3 times, and I'm going to count to 3 while we hold it in. So let's start. Breathe in through the nose. Hold it for 1, 2, 3. Breathe out your mouth. Okay, let's try it again. Breathe in through your nose. Hold it for 1, 2, 3. Breathe out your mouth. Okay, let's do it a 3rd time. Breathe in your nose. Hold it for 1, 2, 3. Breathe out your mouth. Good. So now let's get started with learning what vocabulary words we're going to talk about today. Okay, the first vocabulary word we're going to do is transformations. A transformation is basically a process by which we change or move a shape on a coordinate plane. We could change its location on the coordinate plane, its orientation, or we could change its size. Rigid transformations are one of 2 types of transformations we're going to study today. They're rigid transformations and also non-rigid transformations. Rigid transformations are those that do not change the size of a shape. It may change the location or the orientation, but it never changes sizes. The 3 types of rigid transformations are translations, reflections, and also rotations. Translations are what we like to call a slide. So if we were going to translate this red triangle here, it may look something like that. The blue triangle looks like it is the result of this red triangle translating to the left about 10 spaces. So a translation looks basically like going up, down, or left or right. So it can move in, these directions or these directions. And you can translate it twice and go up and then to the right, or up and then to the left, or down and then to the right, or down and then to the left. Reflections are what we call flips, or just a flip. So when we flip something over, we usually flip it over a line. So we have 2 lines on this graph. We have the x-axis and the y-axis. So if I were to take this blue triangle and reflect it over this x-axis, it's going to look something like that. And notice the size has not changed between the blue and the green or the red, really. Only the location and the orientation has now changed. Notice that the A is on the bottom on the green triangle, but on the blue and on the red, it was on the top. So, when we translated from A, B, C to A prime, B prime, and C prime, it only changed locations. It did not really change orientation. But now it has changed locations and orientations because the A is on the bottom and the BC is on the top, whereas down here the BC was on the bottom and the A was on the top. Rotations are our third rigid transformation, and a rotation is when we turn a shape. And we can turn it clockwise, which kind of looks like that direction. So I'll put a C here for clockwise. And then counterclockwise is this direction. And I'll put 2 C's here so you'll know that's counterclockwise. Now, a rotation can be turned 90 degrees, 180 degrees, and we can go also a whole 360 degrees and end up where we started. But those are the only 3 rigid transformations that we're going to study. Now, I am going to talk a little bit about these little marks that you see. Now, earlier I talked about triangle ABC and triangle A prime, B prime, and C prime. These little marks here are called prime marks, and it's how we can tell which triangle was the original shape that we started with, and then the fact that this blue triangle has now been transformed. So those little prime marks kind of tell us that this triangle here has been transformed and its original place was over here. Now that we've transformed it a second time, notice that there are 2 prime marks on the green triangle. So every time we transform a shape from its original form, we're going to keep adding these prime marks to it. Now, if I were to rotate this 90 degrees clockwise, it would look something like that direction. It would look something like this purple triangle here. So now I've got triangle A triple prime, B triple prime, and C triple prime. And notice that its location changed from the green over to the purple, but it also changed orientation again. Now the B and the C is no longer on the top, it's on the right-hand side of the triangle. And the A is no longer on the bottom, it's on the left side of the triangle. So again, when you rotate a triangle, you're changing its location and its orientation. When you reflect a triangle, you're changing its orientation and its location. But when you translate, you're really only changing its location. You're not changing its orientation. Our next word is congruent shapes. Congruent shapes are what is the result of when we do a rigid transformation. A congruent shape just means a shape that's equal to the other shape. And basically, it's equal in angle measurement, and it's equal in size and angle and side lengths. So this is the symbol. It's basically an equal symbol with like a little squiggly line on top. That's the symbol for congruent. And it just means equal, identical. Non-rigid transformations are the other type of transformation we're going to study. Remember up here, when we talked about rigid transformations, those are these 3 transformations here, because notice all of these do not change the size of a shape. Non-rigid transformations do change the size of a shape. So we're going to talk about a type of transformation that does that, and it's called a dilation. Dilations are when we take a shape and we enlarge it to make it bigger, or we reduce it to make it smaller. So let's look at this little quadrilateral here, this pink one that I just popped up on the screen. Let's say we wanted to dilate this figure and make it twice the size that it is now. So I would increase that by a scale factor of 2. And when I do that, I would end up with another quadrilateral that looks like this. Now notice the original shape, the one in the middle, it's much smaller than the one on the outside. This means that it's a non-rigid transformation because it did change in size. It got bigger, or we call that an enlargement. Now, when you do a dilation, you end up with a similar shape. It's not congruent. Similar shapes mean that the angle measurements are still the same. So notice in the inside of your beginning quadrilateral, each one of those angles is a 90-degree right angle. So the same with the larger angle. Each one of those angles on all four corners are 90 degrees. So they all have the same angle measurements, but the side lengths are different. This side length is only 2 units, and this side length is 4 units. So similar shapes, the side lengths are proportional to one another, but the angle measurements are the same, but they're not identical like a congruent shape would be. Now, what we call an original shape, like this red triangle here, that we don't have any prime marks on, those are called the pre-image. That's the original shape before we have transformed it at all. The image is what the result is after we make the transformation. So images will have these prime marks added to them, but the pre-image will not have a prime mark until it has been transformed and turned into an image. Now, there are 3 essential questions that we're going to learn about in this lesson. The first essential question is define the transformations on a coordinate plane. The second the second essential question is compare and contrast between a rigid transformation and a non-rigid transformation. And the third essential question is name and briefly describe 3 rigid transformations and 1 non-rigid transformation. Transformations. A transformation is a process that moves or changes the size of a geometric shape or a polygon when it is located on a 2-dimensional coordinate plane. Transformations describe how 2-dimensional figures move around a coordinate plane and also how they may have enlarged or reduced in size. Now let's look over here. We have a dilation here. So notice there's a small blue triangle and there's a large red triangle. So if this was the pre-image, if the blue triangle was the pre-image, it would have enlarged to create this red triangle or the image. Now, if we had, if the original shape was the red triangle, then we would have called that a reduction, and that would have reduced down to the blue triangle size. So dilations are a type of transformation that does change the size of a shape. Over here, we've got the 3 rigid transformations. So we've got a translation where it has a slide up and to the right, it looks like, but it's the same congruent shape. We have a reflection where it has flipped or reflected over this y-axis line. And again, it created just a congruent shape that has changed positions and orientation. And then the rotation, it looks like we started off here and then it was a rotation of, looks like about 90 degrees counterclockwise here. And we ended up with another congruent shape, just in a different location and a different orientation. Transformations before and after. A pre-image is the 2-dimensional shape before any transformation takes place. An image is the 2-dimensional shape after a transformation has taken place. So notice this pre-image here, the A, B, and C lightning bolt, does not have any prime marks. However, the image, after it was translated to the right and down a little bit, it is A prime, B prime, and C prime. So we can also write it out as saying lightning bolt ABC has been transformed to A prime, B prime, and C prime. Types of transformations. There are 2 that we discussed. There are rigid transformations that do not change the size and shape, such as in translations, reflections, and rotations. Rigid transformations create congruent shapes. Remember congruent shapes, this is the symbol. So if I were to talk about these 2 triangles here, the original triangle XYZ, I could write that as triangle XYZ. And it is congruent to triangle X prime, Y prime, and Z prime. Now, dilations are a type of transformation that does change the size of the figure. So they are non-rigid. Dilations create similar shapes, not congruent ones. So remember, similar shapes are when the angle measurements are the same, but the side lengths are different and only proportional to one another. So the similar figure shape or symbol is just the squiggly line without the equals under it. So if I was going to say quadrilateral PQRS, is similar to quadrilateral P prime, Q prime, S prime. Ooh, I forgot the R. Oops. See, I like to use my eraser sometimes as well. R prime and S prime. Now, translations. Let's go into that a little bit more detail. There is a video on translations, rotations, reflections, and dilations where you will learn how to work with those algebraically. Right now, I'm just going to talk about them a little bit. So translations can move or slide the geometric shape or coordinate point in 4 different directions: up, down, left, or right. Some people call those cardinal directions: north, south, east, west. The pre-image is called rectangle ABCD. That's this figure here. And it is translated 9 spaces to the right and then 4 spaces up. So the resulting image is now called rectangle A prime, B prime, C prime, and D prime. A translation is a rigid transformation because the resulting image is a congruent shape. The size did not change. Reflections. Now, reflections can move or flip the geometric shape or coordinate point over the x-axis by flipping it up and down, or over the y-axis by flipping it left and right. The pre-image is called triangle PQR, is reflected over the x-axis here, so that the resulting image is now called triangle P prime, Q prime, and R prime. It started here, reflected, and notice the P now is on the bottom, the R is on the top, unlike the one on the top, so it looks like it did flip over there. A reflection is a rigid transformation because the resulting image is a congruent shape. The size did not change. Now, rotations can move by turning the geometric shape or coordinate point into 2 directions, clockwise or counterclockwise, around a central point, which we're going to use the origin. The pre-image called triangle FGH is rotated 90 degrees counterclockwise. So the resulting image is now called triangle F prime, G prime, H prime. So this is where we started, and then we rotated this way. And now the H is on the left and the GF is on the right-hand side of the shape. A rotation is a rigid transformation because the resulting image is a congruent shape. The size did not change. Now, dilations are the one transformation that we're going to study that is a non-rigid transformation. It can change the size by reducing or enlarging the geometric shape using a scale factor. And we will have a video on dilations where we talk about that scale factor. The pre-image called rectangle JKLM is dilated or enlarged using a scale factor of 2. So the resulting image is now called a rectangle J prime, K prime, L prime, and M prime. And it is bigger than the original pre-image by a multiple of 2. A dilation is a non-rigid transformation because the resulting image is a similar shape, not a congruent one, and the size did change. Now it's your turn to try and grow a blossom. So which transformation do you think occurred here, and how do you know? Is the transformation rigid or non-rigid, and explain. So I want you to take some time to pause the video, answer this on your paper, and then in 3 seconds or after a count of three, I will reveal the answer. 1, 2, 3. Okay, so which transformation occurred? Well, because this is the pre-image and this is the image, I know that a reflection most likely occurred over this x-axis. Because if you look at this, the three unit side here is now on the top of the figure, not the bottom of the figure. So this is the one that came first, the pre-image, and then the image is what came after. So it looks like it reflected over this x-axis to make this image here. Its orientation and its location changed. Is the transformation rigid or non-rigid? Well, that's definitely a rigid transformation because the size of the triangle is the same, just the location and the orientation changed. Now it's your turn to try and grow a second blossom. Let's look at these two. Which transformation do you think occurred and how do you know? Is the transformation rigid or non-rigid, and explain. So I'm going to ask you to pause the video and I will count to 3. 1, 2, 3. Okay, this is where the original rectangle started and this is where it is now. Notice that the size of the rectangle is the same, the orientation's the same, but the location is different. So I'm pretty sure this is a translation. So if it's translation, that's a slide, and it looks like this one was a slide to the left in this direction. Oops. My mouse has stopped working for some reason. There we go. Ooh, in that direction. Trying to put an arrow there. From the pre-image to the image. Is a transformation rigid or non-rigid? Well, it is a rigid transformation because the size did not change. It is a congruent shape. Your turn to try and grow a third blossom. So pause the video and I will count to 3. 1, 2, 3. So which transformation occurred and how did we know? Well, this is definitely a dilation. The pre-image was the smaller triangle and the image is the larger triangle. And is the transformation rigid or non-rigid? Well, of course it's non-rigid because the size did change. So this is definitely a dilation, a non-rigid transformation. Okay, the fourth blossom, which transformation occurred and how do you know? Is the transformation rigid or non-rigid, and explain. So now we have a trapezoid here. I'm going to ask you to hit pause and in 3 I will give you the answer. 1, 2, 3. Okay, this is the pre-image and this is the image. So it looks like this was a rotation. So it rotated what looks like 90 degrees this way in the clockwise direction. And the pre-image, notice the 3-unit side here, the shortest side of the trapezoid, is now on the right-hand side of the figure, and the longest side of the trapezoid is now on the left side of the figure. Is the transformation rigid or non-rigid? Well, it's definitely a rigid transformation because the size of the shape did not change. However, the orientation and the location did change. So it is a congruent shape. Okay, now we're going to pause and try to answer the essential questions on our own. So the first question is, define transformations on the coordinate plane. So go ahead and pause and try to answer. Okay, the answer is a transformation is a process that moves or changes the size of a geometric shape or polygon when it is located on a two-dimensional coordinate plane. The second pause and answer the essential question is compare and contrast between a rigid transformation and a non-rigid transformation. So go ahead and pause. Okay, rigid transformations do not change the size and shape, such as in translations, reflections, and rotations. Rigid transformations create congruent shapes. Dilations are transformations that do change the size of the figure, so they are non-rigid. Non-rigid transformations create similar shapes. Name and briefly describe 3 rigid transformations and 1 non-rigid transformation. So I'm going to go ahead and ask you to pause and try to answer that on your own. Answer is the rigid transformations change in either location or orientation, but not size. They include translations, which are slides, reflections, which are flips, and rotations, which are turns. Non-rigid transformations do change in size. Dilations are enlargements or reductions, or enlarge or reduce, and are non-rigid transformations. All right, we did a great job today with our introduction to transformations, and we are going to review our vocabulary one more time, and this happy little hedgehog is going to help us out. So we have transformations, which is a process by which we change a geometric shape by on a coordinate plane by either changing its location, orientation, or size. Rigid transformations are the types of transformations that do not change the size of a shape. The 3 rigid transformations are translations, which are slides, reflections, which are flips, and rotations, which are turns. All of the rigid transformations create congruent shapes. Congruent shapes are those that are equal to one another in angle measurement and side lengths. Non-rigid transformations are those that do change the size of a shape. Non-rigid transformations include dilations, which enlarges a shape or reduces a shape, making it bigger or smaller. This is going to create a similar shape instead of a congruent shape. Similar shapes are those that one is always bigger than the other, and the side lengths are proportional to one another. The pre-image is the original shape before a transformation has occurred, and then the image is the shape that is the resulting, the result after a transformation has occurred. Images also are marked with prime marks so that we know which one came first and which one came second. All right, great work, everybody. A bouquet of math blossoms have opened up in your mind. So to further improve your math language skills, remember to practice by doing your classwork and homework, and also ask for help if you need it. Study 10 minutes every day. Learn from your mistakes. So we will mess up from time to time, and it's okay. Just keep trying and never give up. So I really enjoyed talking to you about transformations today. I'm Miss G, and now it's time for me to say it was lovely teaching you math today. Bye.